Hello, this is Mr. Collier, and today we're solving trigonometric equations. So the first question, find the exact solutions to this equation. We don't want to divide both sides by cosine because then we might lose some solutions. So what we want to do is get everything on one side and equal to 0, and then we can factorize it. So we can factor out cosine. And then we have cosine x equals 0. Or sine x minus 2 equals 0, and sine x equals 2. So this one's impossible because the range of sine is from -1 to 1. So we just need to solve this one right here. Okay, and we need to find the solutions between negative pi and pi. So where is cosine equal to 0? Let's look at some boundary angles. Okay, so this is from between negative pi and pi, not including negative pi and pi. So cosine is equal to the x value, so cosine is equal to 0 here and here. So that is at pi over 2. And the other one is going clockwise to negative pi over 2. So those are our two solutions. Okay, next we are going to solve this equation, and this is just tan theta equal to -1, and tan theta equals -1 in the this is in degrees, so this is in the 45, 45, 90 triangle that we have tangent equal to 1. Okay, so we need to find all the solutions between 0 and 360, and we have tangent is negative here and here, so our answers are going to be, our reference angle is 45 degrees, so our answer is 180 minus 45 degrees and 360 minus 45 degrees. Okay, so our answers are 135 and 315 degrees. Okay, next one. We've got sine 2x equals root 3 over 2. So when we have this question, we have a sine 2x, and we're about to get rid of the sine. We need to change the domain to have a 2x, so I can multiply everything by 2, and we have 0 is less than or equal to 2x is less than or equal to 2 pi. Okay, so now once we have this equal to 2x, we can figure out what the answers are. So this should be 4 pi, right? Twice 2 pi. Okay, so we're looking for when sine equals root 3 over 2. That sounds like this special triangle where we have pi over 3 and pi over 6. 1, 2, root 3. So sine equals root 3 over 2 for the reference angle pi over 3. Alright, and we're talking about positive 3 over 2, so our answers are here and here. Right? So 2x equals, this angle is pi over 3. This angle here is pi minus pi over 3. Okay, but we need to go all the way up to 4 pi. So if you do one complete revolution and then come back to this part again, that is 2 pi plus pi over 3. And if you go all the way around and then come back over here again, okay, that is, well, this is 3 pi if you come over here. So our next answer is going to be 3 pi minus the reference angle, which is pi over 3. So we got 4 answers altogether, and perhaps we'll simplify a bit first. 2x equals pi over 3. And this is 3 pi over 3 minus pi over 3. This is 6 pi over 3 plus pi over 3. And this one here is 9 pi over 3 minus pi over 3. Okay, so then we get 2x equals pi over 3, 2 pi over 3. We've got 7 pi over 3 and 8 pi over 3. Okay, but we're solving for x here, so we have to divide everything by 2, or otherwise multiply by half. So this is pi over 6. Multiply this by half and the 2's cancel. We got pi over 3. This becomes 7 pi over 4. And this one becomes 2 and the 8 cancel to give you a 4 pi over 3. Okay. So those are our 4 answers. And next, find the exact solutions of this. Well, firstly, we need to get rid of this square, so we're going to do square roots. So we have cosine x minus pi over 3 equals positive negative root 1 over 2, which equals positive negative 1 over root 2. Okay, so that occurs in the 45, 45, 90 triangle, or the pi over 4 triangle. So our reference angle is pi over 4. Okay, we're looking at positive and negative answers, so all 4 quadrants. We're looking at all 4 quadrants. But first let's change the domain. We're going to subtract pi over 3, so this domain is going to be actually negative pi over 3 less than or equal to x minus pi over 3 less than or equal to 2 pi minus pi over 3 is 5 pi over 3. Okay, so looking for all the answers in this range. So here we're going to have x minus pi over 3 equals all the 45 degree or the pi over 4 angles in this range. Okay, so let's look down here. So negative pi over 3 is like negative 60 degrees, so it's a bit more than 45 degrees. So our first answer is going to be over here. Okay, so our first answer is going to be negative pi over 4. And our next answer is going to be up here, of course, so pi over 4. Then we're going to have 3 pi over 4s over here. And then we've got 5 pi over 4. Okay, now we're going all the way up to 5 pi over 3, which is actually back to this red part right here. So this is the last of the 4 solutions. Next, we just need to just add pi over 3 to each solution. So we'll have negative pi over 4 plus pi over 3. We'll have pi over 4 plus pi over 3. We'll have 3 pi over 4 plus pi over 3. And we'll have 5 pi over 4 plus pi over 3. And if you get common denominators and add all those together, you will have pi over 12, 7 pi over 12, 13 pi over 12, and 19 pi over 12. So those are our 4 solutions. Okay, let's take a look at the next example. And this looks like, well, it's quadratic, but I can just factor out sine. So sine x outside of 2 sine x plus 1 equals 0. So sine x equals 0, or sine x equals negative half, and in this range. So where's sine x equals 0? That would look at the boundary angle. Sine is the y value, so it's actually equal to 0 here and over here. So x equals firstly 0, and then x equals pi. Now sine is 0 again over here, but it's not including 2 pi, so we do not include the solution 2 pi, so that's it. So this one here, where is sine equal to negative half? Well, sine is negative here and here. Half is in this special triangle. Okay, so sine, when does sine equal half? That is when the angle is pi over 6. Okay, that gives us sine of half. So our answers are going to be over here. Our reference angle is pi over 6, so our answers are going to be actually pi plus pi over 6, and this is 2 pi minus pi over 6. Okay, so let's write out all the answers again. Simplified, 0 pi, this is going to give you 7 pi over 6, and this is going to give you 12 pi over 6 minus this is 11 pi over 6. Okay, next one, solve with the GDC. Okay, so let's use our GDC for this one. So I'll plot. Okay, I got the function already. Oh, that's not the right function. So let me clear that. Oh, I think it was the right function actually. 3 cosine x. Now on the TID4, we need to do 1 divided by a tangent to get cotangent. Okay, so we'll type in that function and see where it's equal to 0. So I'll find the 0 of the function. For my window, I'm guessing this will work, and let's go to 360 because, oh yeah, we're in degree mode. So make sure you're in degree mode. And here's the graph. And you can see there's 4 solutions here, right? So we can solve that by graphing. We can do second, calc, intersect. We can, where's my cursor? Where's my cursor? Oh, here it is. So I'm close to this here. Oh, we don't want intersection, sorry, we want 0. Okay, so 0, let's find 0, let's go to the left, enter, go to the right, enter, go to do my guess. So that one is at 90 degrees. Okay, so that one's at 90 degrees. That's our first solution. Maybe I can include a sketch as well. Alright, looks like this and something like that. So this is at 90, and let's solve the other ones. Our 4 solutions are 90 degrees, 199 degrees, 272 degrees, and 341 degrees. Okay, lastly, we're going to solve this one graphically. Now we can find all the points of intersection. Another thing you can do is, this is a bit easier on the TI-84, is to get 0 on one side and just find the zeros of the function, right? So let's go ahead and do that. Now we're in radian mode, so I'm going to go ahead and change back to radian mode and type in the function 3 tan x. Oh, let's clear this, sorry. 3 tan x minus 2 cosine x, and my window, no, I'm doing it in radians, so I just need to go up to 2 pi. So let's put in pi times 2. Okay. So we're just looking for the zeros. And looks like there's just 2 of them. So let me go ahead and find those. Okay, our first one is 0.524. And the next one is, so the next one is 2.62.